going to interview this one group that doing for the assignment. Let's come with me. Hi Miss.
Yes.
So what's the topic that you have chosen for this group assignment?
So for this group assignment, we have given a topic which is applications of differentiations. So the topic that we chose for our group assignment is actually related rates.
Related rates? What is that? Can you elaborate more about this?
Sure. Related rates is actually a particular problem which involves a functional relationship y equal to fx, which the x and y are also functions themselves, which also related to another variable named t, which is time.
Oh, I see. So this topic relate to our daily life.
Actually, related rates in calculus involves finding how quantity changes with respect to time when they are related to each other through equations. These applications are fundamental in understanding and are widely applicable in our daily life. For instance, filling up the bathtub with water.
Oh, I see. So that's all that you got?
No, actually I want to elaborate more on that example. So, for example, if you want to fill in the bathtub, sometimes you are wondering how fast the water is increasing inside the bathtub. Maybe you can use the time to wait for the bathtub to be full with water. Maybe you can do other stuff first before waiting for the bathtub to be ready for you. So, this is how one of the example is applicable in our daily lives.
Wow, that's interesting topic that you've got. So I wish you guys a good luck. That's all from me. Thank you.
Case 1. Ilya poured a cocktail from a jug into a glass cone-shaped mug, whose height is 1/2 the radius of its base. The cocktails are being poured at a rate of 2 cm³ per second. So, how fast is the height of the cocktail increasing when it's 6 cm high? So first, we have been given dH equal 1/2 R. Then they are equal to H. After that, we need to differentiate. We got dV over dt, which is dV the volume, and dt is the time, equal 2 cm² per second. Next, we need to find the dH over dt when H is equal 6 cm. So here we use the volume of cone, which is V equal 1/3 pi r square H. Then we substitute the R from the first step into this formula for R. So the V equal 1/3 pi 2H square H. We got the V equal 4/3 pi H cube. And after that, we differentiate them. dV over dH equal 4 pi H square. Next, we substitute dH equal 6 into dH, which is the dV over dH equal 4 pi 6 square, and we got 144 pi. The last one, we just need to substitute all the things that we got into this formula we use for chain rule, which is dV over dt equal dV over dH multiply dH over dt. The dV over dt we got from the first step, which is 2. dV over dH we got 144 pi, and then after that we got the dH over dt equal 2/144 pi centimeter per second. So 2/144 pi centimeter per second is how fast is the height of the cocktail increasing when it's 6 centimeter high.
Case 2.
Amina is climbing a 10-meter long ladder resting against the tree to bring a cat down when suddenly the ladder slides down the tree at the rate of 4 meters per second at an instant. How fast is the bottom of the ladder moving along the ground when the bottom of the ladder is 3 meters away from the tree? For this question, imagine the shape when the ladder is resting against the tree. Since it's shaped like a triangle, we must apply the Pythagoras theorem. We need to find the value of dx over dt. So dx over dy need to multiply by dy over dt. Since we can cancel out the dy. By differentiate Pythagoras theorem, we can substitute the value of 3 and 10. Differentiate by using product rule, as we need to carry out the power value to the front and decrease by 1. Don't forget to differentiate the value inside the bracket. The answer for dx over dy would be negative y over 100 minus y square power 1 over 2. So now we need to substitute the value x to the Pythagoras theorem to find the value y. Then after we got the value y, we substitute into value dx over dy. After that, we calculate it to get the answer, which is dx over dy equals to negative 4 square root 91 over 3.
So, for the conclusion, these problems show how calculus helps us solve real-life situations accurately, whether calculating cocktail height in a cone-shaped mug or ladder movement against a tree. Differentiation proves essential in practical scenarios. Through this problem, we see how calculus isn't just a tool for academics but a practical necessity. It helps us understand how quantities change over the time in real scenarios, from cocktail volumes in geometrically complex containers to ladder dynamics against different surfaces. And lastly, these examples remind us of the powerful impact mathematics has on our everyday lives.